Welcome back to another episode of the Recharge Zone podcast. I'm your host, Ann-Margaret Gonzalez, and I'm joined by my co-host, Brent Doty. This year, you've heard from our staff on topics that encompass the vision of the EAA for the next 10 years, the next generation, and beyond. But today, we want to break down some of the most frequently noted myths about the Edwards Aquifer, and some facts about the aquifer that are pretty impressive.
Hi, Ann-Margaret. It's great to be with you today. I'm excited to talk about this topic because over the years, I've heard a lot of myths and a lot of facts about the aquifer. And I've even received a lot of weird phone calls of people asking these questions. So I don't know if my name is at the front desk or something for if someone calls in with a weird question and it goes to me, but sometimes it does. And I even heard one this morning. A friend of mine was talking about, he got a phone call. A lady was asking, how many miles of unexplored passages are there in the Edwards Aquifer, like cave passages?
Yeah.
And he thought about it for a minute, and he's like, well, we don't know because it's unexplored. So how can you know how many miles of cave passages there are?
Oh, that's so true, because it's like the aquifer is not known, like, right?
Right.
So you wouldn't...
So how do you know how much of the unknown there is? So that's just a kind of a funny one.
That's a good one.
Another lady called me on the phone, and she asked me how big the aquifer was because she saw the recharge zone sign, and she thought that's exactly where the recharge zone was, and that was it, that little block there where that sign was.
Oh, wow. I didn't even think about that. Someone could misunderstand that.
Definitely. So, you know, people hear about the aquifer in different ways. Kids that grew up here learn about it in school. We had a long-standing education program that talked about it. Others see the water levels on the news because they show the J17 level sometimes, and they see these green signs around town that say entering the Edwards Aquifer recharge zone. But not many people actually know it to the extent of where it starts and how big it is. So that's the myth there, that it's just small, that it's just here in San Antonio. But actually the aquifer is fairly large and extends all the way from Del Rio up towards north of Austin. So up towards Waco even. So it has different segments of it, the San Antonio segment being the largest and most productive, but it's actually a very large aquifer here in South Central Texas.
And so they call it the San Antonio segment, but essentially it's not just in San Antonio, right? That's just what it's called, the San Antonio segment, right?
Yeah, that's right. The San Antonio segment extends from about Brackettville and Kinney County up close to Austin, the Kyle Butte area.
Yeah, that's so interesting. I think some people don't realize how far the aquifer actually is, like you mentioned, and how far it expands, and that the EAA manages the Balcones Fault Zone Edwards Aquifer. Also, the word or name Edwards doesn't have to do with a person per se, right? Like the type of limestone is Edwards limestone.
Yeah, that's right. So, yeah, Edwards is a typecast for the type of limestone that is made up of the aquifer. And, it was named based on the geology first, before the aquifer. There's actually an Edwards County where the Edwards limestone was sort of first identified and described.
Oh, really? That's so interesting. I feel like a lot of people say, like, well, so who's Eddie or who's Edwards, right? Who's Edward?
Yeah, who's Uncle Eddie, or who is this Edwards person? Yeah, I don't know exactly who it was, but probably an early person or somewhere around that region that they named it after. So another set of myths and facts that people get mixed up about is this idea of karst. Mm-hmm. We hear that all the time because the Edwards Aquifer is a karst aquifer, and so people get that word confused. Mm-hmm. A lot of people think that karst is a type of rock, like a limestone with the holes in it.
Yes.
The vugs, as we call them, that is karst. And that's a bit of a myth because karst is actually describing a type of terrain. So a karst aquifer is an aquifer that's over a karst terrain where you have, it's characterized by disappearing streams, so streams that go underground, that recharge, caves, sinkholes, fractures, faults. It's basically a terrain and dissolvable rock like limestone. So it's not the limestone itself, it's the terrain that it exists in.
So if you have a piece of rock, you can't say, like, this is karst rock. Like, you would say this is Edwards limestone or this is a type of limestone.
Right, yeah, the rock itself is not karst.
Yeah, and I think I've seen people misrepresent that in the past, for sure.
Yep, so that's the fact, and that's the myth, and the fact is that it's a terrain, not a rock.
But like you mentioned, once it's clarified, it makes a lot of sense. Like when you explain it that way, that's like a fact that I won't forget.
Another thing I hear a lot, and this is a bit of true and false, is that the water in the aquifer is ancient, like as old as the dinosaurs. So I hear that a lot. Oh, this water was, from the time of the dinosaurs. And the truth of that is, it is part of the water cycle, so the water is constantly recycled, perpetually recycled. So it is, ancient water, as you would say. But it hasn't been underground that long, or at least likely not. The water is very, what we call heterogeneous, which means it mixes, it's well mixed. So you have a mixture of very new waters and some older water, but the water could be as old as a few days or a few years, but certainly not all as old as the dinosaurs.
Oh, interesting. And so kind of going to that fact that you just mentioned, but all water that's ever existed on Earth is all water that will ever exist, right?
Yes. It's all part of the water cycle. It's started as soon as the Earth had water on it. You had evaporation, you had precipitation, and it just keeps going around.
Yeah.
But the water in the aquifer is discharged through the springs, re-enters the system as recharge, and is constantly also in a pattern.
Yeah.
So it's constantly being recharged and discharged and changed.
So kind of going to the topic of water and the water inside the aquifer, at some of the events and things that we've had in the past, people have either thought that the water is perfectly filtered or that it's dirty. Can you explain what the case is?
This is another one I get, because I was at New Braunfels one day at the springs there, Comal Springs, and I was down by the little spring pool. We call it Spring Run 1. And a guy was filling up this jug of water right from the springs, and he was drinking it right from the springs. And he said, yes, this is the most rejuvenating water, best tasting water anywhere. And I'm sure it tastes good, but the fact is that although some filtration takes place in the aquifer, especially a karst aquifer, it cannot filter out all types of contaminants.
Yes.
So you're going to have just naturally occurring bacteria. It could have some trace chemicals in there. These void spaces that the water is moving through are very large, and the water moves fairly rapidly, and in some cases more than a mile a day. So with flow rates like that and the void spaces, the size of them that it's moving through, it just doesn't have a chance to filter out everything. So it does filter, but not perfectly. So the guy with the jug of water, I wouldn't necessarily recommend that. Not that we have dirty water here. We certainly have really clean water. But karst aquifers in general aren't always perfect at filtering.
Yeah, and like you think about it too, like runoff, you don't know if you're getting water from a source like that, right? Like runoff from pets or something like that. That's why they have those signs up in parks and whatnot, right?
Yeah, that's why we spend so much time and effort on prevention here in San Antonio. We have rules about hazardous substances over the recharge zone, about regulated facilities that have above or underground storage tanks. All of this to prevent spills from happening, because once they happen in karst terrain, it's difficult for it to be filtered. It's difficult to remediate that spill.
Yeah, that makes complete sense. That's why, that's essentially why we exist, right?
Yeah, that's a big part of the EAA. It's not only about quantity, but also the quality of the water, and that is why, because the aquifer is sensitive to contamination.
So speaking of quantity of water, I've heard people refer to the aquifer as an underground river or lake. Where do you think this myth began, and why is it inaccurate?
I think it began because it's just easy to visualize that. We've all seen lakes and rivers, and so we understand what those look like, that they look like, big storage of water. So when you think of the aquifer completely full of water, it's just easy for people to think of it as a giant underground lake, like a reservoir, or like a river flowing, because we also know that it flows. So the only water I've seen flowing is from a river, so it must look like that.
True, I see.
So it's hard for people to conceptualize. If you look in the early like Supreme Court cases, they talk about it like an underground river.
Really?
Or they'll say that it's too mysterious to understand.
Interesting.
But in reality, it's just saturated rock. The water does move through conduits or passages through the limestone. And so that's as close as it gets to an underwater river in some parts, but it's really just saturated rock. So put a bunch of rocks in a bucket and fill it up with a hose, and that's what it is. But it's 500 feet thick, 450 feet thick.
Yeah.
So that is a lot of water through all these tiny little cracks and pore spaces in the rock, but it's not a big reservoir. It's not, Lake Michigan under there.
Yes. So could you say, like, I know you mentioned obviously Edwards limestone is what the aquifer is made up of, but could you almost say that it's like in certain places the void spaces or the vugs, like you mentioned, are as big as like a penny or larger, or like large like caves, right? And then could you compare it to like a sponge?
Yes, that's right. It's very much like a sponge. If you think of how a sponge has tiny little holes in it, but they're not all completely connected, and the water is still stored in there and moves through it. That's how it is. So when you think of a limestone rock, limestone in its original form, it has the same kind of porosity and permeability as like concrete. It really can't move a lot of water. But if you dissolve out little void spaces in that concrete, holes in there, all of a sudden the water can move readily through it. And that's what what's so special about limestone and dolomite and these other soluble rocks is after millions of years, water has time to work through it and to dissolve it out and to create cave passages and conduits that are connected and that do form kind of preferential paths for the water and can store and move a lot of water.
I didn't really think about that. So basically what you're saying is like a true piece of limestone, like a quote unquote fresh piece of limestone, is not going to have those void spaces. Millions of years made that happen.
Exactly. And in the case of the Edwards, it was enhanced by a time when we had a lot of earthquakes and faulting here, when there was some mountain building out west and there was some sort of kind of sloughing the rocks off towards the coast. That fractured the rock. And those fractures over time had a chance to also enhance the flow paths and become larger and create void spaces. So it wasn't just the limestone, it was also the movement of the limestone over a long, long period of time.
Because once upon a time, this area of Texas was an ocean, right?
Yes, it was kind of like a warm, shallow sea, and there was actually a couple of different sort of, we call them transgression and regression, so the sea moving up and coming and eroding rocks and then creating new rocks. So it was a kind of a complicated geologic history. But yes, this place was at one time an ocean and then later kind of a tidal flats. And that's why we have sort of a lot of areas have dinosaur tracks, because the dinosaurs were walking in this sort of tidal flat area. Think of it like a sort of kind of muddy flat area.
Okay.
And then that was covered and buried. And then now you have dinosaur tracks exposed in some areas.
That's so neat, right? That's so fascinating. I think most people don't realize that, right?
No, yeah. It's you really have to look closely and you have to examine the rocks. And if you look closely, anybody can do this. Go out and find an exposure of rock, and you'll likely find some kind of fossil in there. And it'll be a marine fossil, so it could be like a clamshell, or maybe a little snail shell or some kind of marine fossil that'll give you an indication of where it was from. But most limestones were formed from calcium carbonate, so the breakdown of sea life.
Wow. Okay. Yeah, that makes complete sense. So speaking of how water doesn't penetrate through limestone so easily, is there a final like end place when the water, goes through the Edwards Aquifer system? Does the water find a final destination, or it just like kind of fills up?
Well, here's the story of our aquifer. Of course, it rains, and that rain, some of it's directly recharged. In other cases, it feeds into a stream or creek that flows into the aquifer over the recharge zone. And then once in the aquifer, it's still following the laws of gravity, flowing south and east towards our spring systems and towards discharge points. So it comes out at San Marcos and Comal Springs and other springs in the area. And once it comes out of there, it goes back into the rivers and it heads towards the coasts, where it actually plays a pretty vital role in maintaining sort of this freshwater, saltwater balance in the estuaries that a lot of sea life depend on, including like blue crab, which is a favorite of the whooping crane.
Wow.
So it's all this,
like a symbiotic relationship.
It's all, kind of like that, and it's all interconnected, and it's a 100-mile long plus chain of events that happens.
Wow. So sometimes I've heard people ask the question, are we going to run out of water in the aquifer?
I get this one a lot too, and sometimes from the phone calls, especially during a drought. And the fact is, we're trying really, really hard to maintain sort of the top 5%, 10% of the aquifer. And the reason we do that is to make it sustainable. So we don't want to be pumping out and using more water than we recharge every year. And of course, the amount of water that recharges every year differs based on how much rainfall we get. Mm-hmm. So in a year when it doesn't rain a lot, we want to, of course, use less water to maintain that sustainability. So that means we want to keep these springs flowing. So no, we're not going to run out of water. Technically, there's a lot more water in there, but if we just used it without worry or without conserving it, all of a sudden we would start mining the system. We would mine the water to a point where it may not be,
like readily available,
or it may not recharge enough to have these springs continually flowing.
Oh, yeah.
And there are some examples of other aquifers in Texas where they have mined it to the point where these perennial springs no longer flow.
So that's obviously why our critical period management is so important to like the region, right?
Yes, it is an example for other regions and systems to follow. What we're doing is basing the natural conditions dictate how much water we can use. Mm-hmm. So if our springs are starting to go dry, we cut back on the amount of water we use. And same with the water levels. If our monitoring wells show declining aquifer conditions, we immediately cut back. And I think that's what you have to do in a system that relies on natural recharge every year, is to figure out how much recharge there is, how much water you can use sustainably, and come up with a management system that operates within those boundaries. Okay, Ann-Margaret, this has been really fun talking about Fact or Fiction Aquifer Edition. It's really had me reminisce about some of the phone calls and questions I've received over the years about, myths or facts about the aquifer. So it's been fun to talk about those and give folks some answers.
It's educational, but also kind of fun, right? To hear some of the myths, but then it's also very informative to hear the facts. I mean, there's many facts about the aquifer.
That's right. And we will see you next time.
Thanks for tuning into this episode of the Recharge Zone podcast. Have questions, ideas for topics, or things you would like to share with us? Well, reach out to us at rechargezone@edwardsaquifer.org.